The waves were calm that night, too calm. Fishermen along the Korea Strait swear they saw something strange on the horizon. Not a ship, not a storm, but a shimmering line where sea met sky, as if the past itself was trying to surface. Most people would ignore a story like that, but not geneticists, because buried deep in the blood of two nations, Japan and Korea, lies a mystery that has puzzled scientists for decades. A mystery older than kingdoms, older than language, older even than the first rice fields. A mystery that begins long before the first human ever stepped onto the islands of Japan. Long before the first village was built in Korea. A mystery written in the double helix. Tonight, we're not telling the political story or the cultural story. We're telling the genetic one, the one the bones and blood refuse to hide. If you've ever wondered where people really come from, if history, archaeology, and ancient DNA fascinate you, subscribe to this channel. We bring forgotten genomes to life and decode the hidden migrations that shaped our world. Now, let's open the story. Because when we compare Japanese DNA and Korean DNA side by side, the result isn't just surprising. It rewrites everything we thought we knew about East Asia. Imagine your DNA as a colossal archive, older than any temple or palace. Every page written in 4 letters, A, C, G, and T. Billions of characters long. You can't flip through it, but scientists can. And what they find isn't just biology, it's migrations, founding clans, lost civilizations, and ancient families who shaped entire nations. The most powerful clues are haplogroups, genetic signatures passed down through thousands of years, passed only from father to son. Like a surname carved in stone, it travels through time almost unchanged, tracing deep paternal ancestry. mtDNA, passed from mothers to all children, a continuous chain of women stretching back to prehistory. By comparing these haplogroups in different populations, scientists can see who shares deep ancestry, where ancient migrations began, how far people traveled, when populations split or fused. For Japan and Korea, haplogroups are the key to a story that begins not in history, but in the Ice Age. The Korean peninsula looks like a narrow stretch of land, but genetically it is a crossroads. A place where humanity has flowed like tides for tens of thousands of years. 40,000 to 50,000 years ago, the first Koreans, Ice Age hunter-gatherers, moved east from Central and Northern Asia, reaching the peninsula while following herds and coastlines. Their genes survive faintly today in Koreans, preserved in certain mtDNA and Y-DNA lineages linked to ancient foragers. 6,000 years ago, the farmers arrive. A massive shift came when early rice and millet farmers expanded out of the Yellow River and Yangtze regions. Archaeology and genetics agree. These Neolithic farmers poured into Korea, blending with the foragers rather than replacing them. Their signature? Y-DNA 02M122, one of the most common haplogroups in Korea today. Steppe nomads and empires. Korea sat in the path of powerful northern confederations, Gyeongnu, Dak, Khitan, Yurchin. Mongol tribes. Small but measurable haplogroups like CM217 reflect this influence. Chinese dynasties. Centuries of contact, from the Han to Ming periods, brought additional genetic layers. Not dominant, but detectable. Despite waves of migrations, centuries of war, and enormous cultural exchange, modern Koreans are one of the most genetically homogeneous populations in the world. Their DNA tells a story of blending, a harmonious fusion of foragers, farmers, and steppe influences. But what happened across the sea would unfold differently. If Korea is a bridge, Japan is a cauldron, where migrations mixed, but never fully merged. 30,000 years ago, the Jomon arrive. These early hunter-gatherers reached the islands via land bridges during the Ice Age. They developed unique pottery, distinct physical features, a genetic profile found almost nowhere else. Jomon DNA includes maternal haplogroups like N9b and M7a, still present today. 2,300 years ago, the Yayoi migration. This is the event that reshaped Japan forever. Farmers from the Korean peninsula, genetically tied to Neolithic Chinese agriculturalists, crossed the sea into Kyushu. They brought rice farming iron tools, horses, new social structures, new haplogroups. The Yayoi didn't wipe out the Jomon. They blended, but unevenly. Modern Japan, a dual ancestry. Most Japanese today are 80 to 90% Yayoi, 10 to 20% Jomon. But the ratio changes by region. Ainu of Hokkaido, higher Jomon. Jard, Ryukyuans, higher Jomon. Central Japan, higher Yayoi. This layered ancestry is the reason Japan's genetic map is so textured compared to Korea. Later influences. Small additions came from Chinese contact, Buddhism and cultural exchange, Mongol invasion attempts, Portuguese arrival. But none altered Japan's core dual ancestry. Place both genomes side by side, and the patterns become clear. Shared origins. Both populations descend from ancient Northeast Asian hunter-gatherers, Neolithic farmers from northern China. This is why genetic studies consistently cluster Japanese and Koreans close together. Key differences: 1. Korea. Homogeneous centuries of blending created a tightly unified genetic profile. 2. Japan. Layered. Two ancient lineages coexist. Yayoi, related to Koreans, Chinese farmers. Jomon, unique to Japan. 3. Haplogroups. Korea, dominated by O2M122. Some northern haplogroups like CM217, Japan shares O2M122 via Yayoi, but also has DM55, N9b, M7a, Jomon markers almost absent in Korea. Korea tells a story of blending. Japan tells a story of preservation. And the key connection is undeniable. Without Korea, Japanese DNA, as we know it, would not exist. The Yayoi, who shaped Japan's agriculture, population, and much of its DNA, came through the Korean peninsula. Genetics doesn't stop in prehistory. China's influence, far stronger on Korea, weaker, but still present, in Japan. Nomadic steppe influence, present in Korea, almost absent in Japan. Colonial period, 1910 to 1945. Forced migrations between Japan and Korea blended the gene pools further, especially in major cities. Modern globalization. Both populations are now spreading worldwide. New genetic signatures will slowly appear over generations, but the deep foundations remain unchanged. Put simply, Korean DNA, a story of a bridge, foragers plus Chinese farmers plus steppe nomads, blended into one of the world's most unified genetic profiles. Japanese DNA, a story of a cauldron, Jomon, ancient islanders, plus Yayoi, farmers from Korea, a dual ancestry preserved across millennia. Together, they tell a deeper truth. These two nations, often seen as separate, share roots older than any kingdom, any war, any border. Their DNA is proof that human history is not about isolation. It's about connection. And in the end, we learn something universal. Genetics doesn't divide us. It reveals how deeply intertwined humanity truly is.